With 4.5 billion passenger trips taken each year and more than 16 million planes taking off annually in the US alone, commercial airlines provide affordable travel on a global scale. But the aviation industry has a big issue: emissions. Aircraft are responsible for 2.5% of global CO2 emissions, and the problem is growing.
Aviation is one of the few sectors whose emissions are actually set to grow as opposed to decrease over the next few decades.
To combat this, the industry has agreed to try and achieve net zero emissions by 2050.
We've seen a much bigger push from airlines and from companies throughout the aerospace supply chain that in the long term, the biggest challenge facing the industry is emissions.
The airlines are constantly asking the manufacturers, we want to burn less fuel. It's not just about being green, it's millions of dollars difference any fuel savings that they have.
Electric aircraft are being explored, but until more energy-dense batteries exist, they are limited in range.
You can't carry enough batteries to sustain flight because they're just too heavy, even with the next generation of batteries, unfortunately.
But there could be a solution that rivals the power of fossil fuels without the negatives: hydrogen. Hydrogen has the highest energy per mass of any fuel and doesn't release any emissions.
Hydrogen is about 3 to 4 times lighter than jet fuel on an equivalent energy basis. In fact, it is the lightest weight energy carrier outside of nuclear fuels. This is why hydrogen already gets used as a fuel in space launch.
The promise of a zero-emission plane that could compete with jet-fueled aircraft has everyone from big players like Airbus to new startups exploring the technology.
There's been some successful flights, in fact, but it's all been on small regional aircraft.
And with the aviation market expected to grow, this new technology could represent a big opportunity.
We have today $1.5 trillion market that we are transforming and we need to transform. The growth rates are some of the highest of all transportation types.
All the technology is here today. Now is the perfect time to use hydrogen to overcome this issue of climate change.
Hydrogen is the universe's most abundant element. It's everywhere, it's in anything. It's number 1 on the periodic table, but actually getting it and using it as a form of clean energy has been very tough. For the last 30 years, a lot of big companies around the world have been trying to figure out how to make hydrogen attainable, use it as a power source for a fuel cell, as a stationary energy source, a way to power buildings. It hasn't really worked out up to this point, but the last few years, things are beginning to change.
Excitement is building up specifically around green hydrogen. This is a way of making hydrogen that uses zero carbon inputs and produces no emissions other than oxygen. In the US, nearly all of the hydrogen used in oil refining, food processing, and other industrial processes is considered gray. This means it is extracted from natural gas using processes that generate carbon dioxide. If green hydrogen can be used at large scale instead of gray hydrogen, this would make it a powerful tool against climate change, an unlimited source of energy, and a very lucrative business internationally.
We're in Rochester, New York at Plug Power, which wants to be one of the leaders in this new emerging technology, manufacturing both fuel cells, which can power a vehicle or generate electricity on a stationary system, and also making electrolyzers, devices that take water and electricity and make hydrogen to power those fuel cells. And we're speaking with Dan O'Connell here at the Gigafactory that Plug runs. And tell me a little bit about what we're looking at here. This is an electrolyzer, and what does the electrolyzer do exactly? How does this work?
This is an electrolyzer, and this is a 1 megawatt unit. And what this means is we can put a megawatt of power into it and make 420 kilograms of hydrogen. What we do is we put electricity in, we put purified water in, the catalyst inside splits apart the hydrogen and oxygen and water, and we capture that hydrogen and use it to fuel vehicles. Depending upon the capacity of the hydrogen on board storage inside the vehicle, but they usually use around 20 kilograms, so you could probably fill about 20 vehicles off of 1 megawatt electrolyzer. Or you could think of it as like 400 standard sedan vehicles.
Next to you, we have the fuel cell stack. What is this doing?
Yeah, you can think about the electrolyzer splitting the water into hydrogen and oxygen and requiring power. Here we want to take that hydrogen and turn it back into water by combining it with oxygen and thereby generating electricity and use that electricity to do some work for us.
Plug Power's technology supplies hydrogen for a number of applications, including as a fuel for stationary energy generation and fuel for trucks. But the company's primary market is material handling in the form of hydrogen-powered forklifts. Plug Power says about 65,000 forklifts are being powered by their hydrogen at large companies such as Amazon, Walmart, and Home Depot.
So a forklift driver will drive up to a pump, just like you do today, make a couple of connections, and once those connections are made, you'll be able to put a kilogram of hydrogen on board the forklift and be able to run for 8 hours.
And the hydrogen's coming out in what form? Is it liquid? Is it gas?
No, it comes out as gas at 350 bar or 5,000 psi. We take the water off, and when we get all the data off, every time it refuels, we monitor everything going on with that stack inside of that fuel cell unit to be able to determine what's going on. We can predict life, we can predict component failures, so it's really a wealth of data that we get every single time it refills.
When did the transition really happen where you started to see hydrogen fuel cell powered forklifts replace other types of technologies?
Yeah, about 8 or 9 years ago, we started a small fleet at Amazon, and we had half of them with batteries and half of them with fuel cells. The forklift drivers loved the fuel cell ones because of what we talked about, the power, the range, and the recharge time. So the fuel cells started to win out. We've seen probably around a 10% efficiency improvement at those warehouses where we've converted over to fuel cell.
Another big player in the green hydrogen race is a company most people would probably not expect. Cummins, the world's largest diesel engine maker. Its clean tech division is known as Accelera, and we had the chance to visit its Canadian operations in Mississauga, Ontario.
At this facility, we actually have a number of buildings. The building that we're in right now is a building we kind of refer to as the fuel cell building or the fuel cell technology building. In this particular building, we do have a small manufacturing cell that makes fuel cells for general use in various industry, as well as we develop the next generation of fuel cells. We have a large R&D component to the folks that work here. About 30 years of history we tried to capture in this small museum. And what you're seeing here, Alan, across the shelving is a progression of fuel cell technology development that started off way back in the mid-1990s when we became, first of all, a test station company that was building test stations which people who were developing fuel cells would need. And then we started to test people's fuel cells until we finally ourselves decided to go into the fuel cell business with special focus on commercial vehicles. So we were not a fuel cell for passenger car company, we were a fuel cell for commercial vehicle company as Hydrogenics. And in the shelving units here, you see a number of years, to the 2000s, the early 2000s. In these days, we were making fuel cells that when they lasted an hour or a day, we'd pop champagne bottles, if you will.
So here at this facility, you're developing high-powered fuel cell power systems and electrolyzers, but on the fuel cell stack, the fuel cell motor, or engine, I guess, if you want to call it, you're developing something that would be very powerful enough to actually operate a Class 8 semi-truck. Tell us a little bit about what we're looking at right here. What is this unit exactly?
Yeah, this is powerful when paired with its brother, another one just like this. So it's twin, I will say. This is our 4th generation fuel cell, which really shows the commitment that Cummins and Accelera have had to continuing to develop this technology over time. We started with our 1st generation of fuel cells and 2nd and 3rd in the 30, the 40, the 45 kilowatt spaces. Those were low pressure technology. As we advanced the technology, what we found was that we needed to move to a variable pressure, which allows for more power density. This is a 150 kilowatt stack, and as I mentioned, it will be paired with another. We're taking a modular platform approach to have 300 kilowatts of power to commercialize the system for heavy-duty vehicles, Class 8 in North America.
Obviously, you know, Cummins is a giant in the trucking industry. It's the world's largest diesel engine manufacturer. Is it a little curious that it's also pivoting into something like hydrogen fuel cell, which would seem to be a competing technology eventually with its diesel tech?
We actually see the diesel technology as an enabler to get to more advanced technologies because we're leveraging the innovation of Cummins, which is a company that's over 100 years old. We have significant experience in terms of understanding applications and duty cycles and how the products work in the real market, and then we take that and the system integration skills we apply to the hydrogen to the hydrogen fuel cell. So we actually think that the core technology is a huge enabler as to why we're able to be successful in the long term with our Destination Zero strategy.
To see some of Accelera's hydrogen trucks being worked on and driven on public roads, we toured its facility in West Sacramento, California.
Here at the West Sacramento facility, we do powertrain integration and we focus on fuel cell powertrains. So we install fuel cells, we install batteries, motors, everything to make the trucks run as a fuel cell vehicle. And then we do testing out of this facility and we do support for service and validation. So the range we're hoping to get, it varies by application, but when we look at long haul trucking, for example, we're targeting at least 500 miles, preferably even 600 or 700 miles in the long run, maybe after 2030. But in the near term, we know we can get 450 miles in a trucking application, a Class 8 truck. That's really exciting because there are battery vehicles, Class 8 trucks, that can get around 300 to 400 miles. But when you put the full weight and the full drive cycle that these trucks are going to be put into, they don't get 450 miles, contrary to what some battery electric vehicles might say. And so for those really intense applications, 450 miles is a really big deal for a zero-emission powertrain.
In addition to long-distance trucking, Accelera is also involved with hydrogen-powered trains. It already has a number of clean trains running in Europe in a partnership with Alstom. And recently, it helped power the first hydrogen train in North America.
This is what we call an FCC, a fuel cell composition. This fuel cell composition also goes in pairs. There are two that are mounted to the roof of passenger trains.
Okay.
And Accelera is actually powering the world's first hydrogen-fueled commercial passenger train in operation in Germany.
In Germany.
We've already delivered over 40 trains. We have another 10 that are being delivered later this year and then several next year as well. So our European fleet will actually be very substantial in size.
Right.
Just this summer, here in Canada, up in Quebec, we ran a demonstrator train for 3 months, from June just until the end of September when it concluded, from Quebec up to Charlevoix, and it was the first North American passenger train powered by hydrogen fuel. And the reason we wanted to do this demonstration project, which is also in partnership with our key customer in Europe, Alstom Trains, is to show the marketability and the capability of hydrogen propulsion technology across different environments and different duty cycles. And one of the things that made that demonstrator project really unique was that it encompassed the whole end-to-end hydrogen ecosystem. The hydrogen that was powering that train was created by an electrolyzer purchased by another one of our partners, Hanwha Energies. Accelera was able to provide the electrolyzer, which generated the hydrogen, which then powered the hydrogen fuel cell train.
The train we brought to Quebec is one of the test trains that we had for the testing campaign for the first generation, because we wanted to make sure we actually demonstrate its operability here in North America. The feedback has been great, and frankly, passengers, but also we've had a lot of delegations, international delegations coming, having interest in the train. Governor of Massachusetts and Vermont and Maine came to actually tour the train, and everyone realizes that first, it's real, it actually carries passengers, it's smooth, it's very quiet, it's an enjoyable ride. So we've had tremendous feedback.
To get a closer look at Accelera's electrolyzers, Alex Savelli, the company's managing director for hydrogen technologies, walked me through an assembly area. He tells me one of these machines uses about 5 megawatts of input power and produces about 2 tons of hydrogen per day.
So that would be, to put in perspective, would be enough to run about 60 buses, like on the type of transit application for a day.
Okay.
But then you have some customers that want sometimes 3, 4, 5 of these machines. One customer that we have, Air Liquide, up in Bécancour, north of Quebec, has actually 4 of these machines. And they're basically using it for industrial gas production, but that plant has been running for almost 3 years now. It's actually the largest PEM plant operating in the world today.
Who are your primary customers? Who is buying these?
In the short term, a lot of the industrial gas companies, the merchant gas companies, folks like Air Liquide, Linde, Air Products. But we also have, also done a few projects with, folks in the power generation space. So the first 5 units that we produced out of here, they're in the process of being commissioned at Florida Power and Light.
Okay.
And they're going to basically be producing green hydrogen to decarbonize power production. So they're going to blend some of this hydrogen in a combined cycle turbine that today uses natural gas. They'll start blending hydrogen to decarbonize, electricity production. We also have sold quite a few of these, some of these semiconductor plants. They're being, inshored back into the U.S., from the CHIPS Act. Hydrogen is one of the gases you require to produce chips. And then, more recently, there's a lot of interest in e-fuels. So if you think about sustainable aviation fuel, e-methanol, ammonia, all the way from smaller projects to very large projects, for that type of application. The beauty of hydrogen, if you think about it, it's a very versatile molecule, right? Because it can be used as a fuel for mobility, but then it can also be used as an energy carrier. So if you want to move, molecules from North America to Europe, sort of help with some of the energy crunch that Europe is going through, you can also use hydrogen for that.
So with all of its potential, what are the remaining obstacles for green hydrogen to be more widely used? One significant factor that Accelera, Plug Power, and other hydrogen companies are waiting on is a production tax credit for clean hydrogen in Section 45V of the Inflation Reduction Act. In particular, they're waiting for the U.S. Treasury Department to clarify guidelines on what forms of hydrogen fuel will qualify as clean and low or no carbon enough to receive a tax credit. The cleanest methods of hydrogen production would qualify for up to $3 per kilogram. But if the guidelines are made too lenient, there is a fear that less clean hydrogen production could create millions of tons of greenhouse gas emissions and undermine the cleanest hydrogen producers. Another factor to consider is the U.S. Energy Department's recent designation of 7 hydrogen hubs across the country that will share $7 billion in government funding and $43 billion in commitments from companies. At Plug Power, I asked the company's VP of Electrolyzer Technology, Courtney Mittelstadt, for his thoughts on hydrogen's future.
What do you think needs to happen and what's going to happen to sort of build out the hydrogen economy and make it a more widely used energy source in a range of applications beyond what it's going into today?
Yeah, absolutely. That's a great question. And what will happen and what it comes down to is the cost. Of course, it's absolutely the cost. So originally, where you're seeing the hydrogen, where Plug was able to find a niche for hydrogen right from the beginning was for the forklift trucks. So there, even electrolysis can be competitive right now because the hydrogen has to be at high pressure and it has to be very, very pure to operate in a fuel cell. So in that small market, we can compete today. We're getting, as our costs come down, we're getting the next area that's willing to pay a little bit of a price premium is hydrogen as a chemical, not hydrogen as a fuel. But what's also coming down, what affects us even more than our cost is the cost of the renewable energy. Renewable energy, as you know, solar and wind, those costs continue to come down and down. So for instance, if in some areas, the cost of solar is as low as 2 cents a kilowatt hour. Now it takes 50 kilowatt hours to make 1 kilogram of hydrogen. Okay. And 1 kilogram of hydrogen is about the equivalent of a gallon of gasoline. So again, you get that green solar hydrogen for 2 cents a kilowatt hour, and you use 50 kilowatt hours to make a kilogram of hydrogen. So you can see how quite quickly we can get under $2 for the cost of a kilogram of hydrogen. The Department of Energy has a goal for it to get all the way down to $1. Right. And at $1, we are competitive in so many areas, and that's why you see the enthusiasm for hydrogen so high now.
Certainly one of the challenges is understanding the adoption curve, understanding the demand and how fast that will grow. And I think the factors that are affecting that adoption are price of hydrogen and infrastructure, so availability. So the customers aren't going to say order 1,000 trucks if they don't have a fueling station for 1,000 trucks, right? So infrastructure is one of the main challenges. The other is cost. Right now, the material to make fuel cells and the other parts of the fuel cell electric vehicle are still a little bit expensive, and so there's a cost premium over a diesel and even over a battery electric, but that cost is coming down, and that's partly what we're trying to do is get that cost down. And so when the cost comes down and the infrastructure is available, then the TCO, we call it, the total cost of ownership for our customers, will make sense, and they'll be able to basically replace their whole fleets with fuel cell electric trucks.
There are still a number of things that need to happen to make that a reality in North America. On the infrastructure side, the production of hydrogen, for example, is high on the agenda across US and Canada, but investments have to be made to really produce hydrogen. Green hydrogen is better, obviously. It's coming from renewable electricity. And then there's discussions that have to happen around distribution of hydrogen, the network and stuff like that. And then the incentivization of that kind of initiatives against keeping kind of the old diesel trains. We have in North America 27,000 diesel locomotives, and the territory is pretty much not electrified. 1% of the tracks are actually covered by catenaries, and that's to be compared to 60% in Europe. So there's a huge fleet which needs to be replaced at some point, and there's a very low electrification rate. So in essence, that could be really a perfect match to trains like that, which are basically running without catenary at zero emission. But there's a lot of things that need to happen, and some states are moving faster than others, but definitely something that we're watching, and we want to mature the technology and make it fit for the conditions that we have in North America. The long distances, the big freight trains, for example, require a specific design that we're still maturing.
Clearly, there's still a lot more that needs to happen before green hydrogen is as present in our lives as gasoline or batteries. As other large economies such as Japan and Australia set their strategies for competing in the hydrogen space, the U.S. will have to make sure it can ensure its role as a major player. And the decisions it makes now, particularly around how to define clean hydrogen, could determine future jobs, pollution levels, profits, and whether or not America will hit its net zero emissions targets by 2050.